Hey, we are solving equations with variables on both sides of our equal sign today. Go ahead and throw your name on here, and it is currently second hour. Okay. Paying attention to details is more important now than ever. When you have variables on both sides of your equal sign, you got to get them all to one side in order to solve for x. Because you can't solve for x if it's in two places. You got to put them all together so you can solve for x. When something is on the same side of an equal sign, it can just get combined like normal. When something needs to move across the equal sign, you have to use opposite operations. So we will use opposite operations to move all of the variables to one side of the equation. You can move everything to the left. You can move everything to the right. And when I say everything, I mean all the variables. So you can move all your variables to the left. You can move all your variables to the right. You can move all your variables, whichever side is going to make it positive. I know that there are a lot of you guys that like structure and doing the same thing every time. So in notes, I am always going to move all of our x's to the left, and then we will solve from there. If there are times when you would like to move some of them to the right to avoid negatives, you can. But for notes, I am always going to move to the left. So, put my line down my equal sign here. My first problem, I've got 3x minus 3 equals 2x minus 9. I am always going to move my variables before I move my constants. Because if you move your constants first, then sometimes you end up with nothing. So I am going to take that 2x that's on the right, and I want to move it to the left. How I get it off the right side is subtract 2x. Anything I do to one side of the equation, I have to do to the other. And I do it to the x's since that's what I'm combining. Then I have 1x minus 3 equals, so I subtracted here, sorry. 3x minus 2x is just 1x. So I've got 1x minus 3 on the left. On the right side, this 2x minus 2x zeroes out. And I've got negative 9 on the right. Okay, from there, it's a normal equation, what we've been doing since 1.1. I'm going to add 3 to both sides. I have 1x equals negative 9 plus 3 is negative 6. And then I don't actually need that 1 in front of my x. 1x is just x. So x equals negative 6 on this one. We could show ourselves dividing by 1 if we wanted, or just like we could add in those imaginary ones, we can take them away. Okay, so variables on both sides. I move all of my variables to the left, then I solve like normal. Any questions right now? Okay, here's where this next piece comes in then. If there is anything that needs to be distributed or combined, we want to do that first. So these next two, we've got this 7 and 18 that can combine. We've got this negative 3 that can get distributed. Do that first. Get each side settled, then move things to one side or the other. So this next one that we've got, 6x plus 7 plus 18 equals 10x minus 3. I'm going to combine that 7 and 18 together. They are like terms, so they just combine together. We don't do opposite operations when we're on the same side. So my 6x stays. My 7 and 18 combine together to be 25. I still have equals 10x minus 3. Okay, at this point, if you are a person who prefers positive numbers over having your x's on the left, You could subtract 6x from both sides, but then the x that you're solving for would be over here. I prefer having my x's on the left. I think that's more stable for you guys to just always do that and never have to decide. So that's what I'm going to do in notes. But if you understand it and want to do it the other way, go off. So right now, the next thing, now that I just have x and a constant, I'm going to subtract this 10x. So 6x minus 10x is negative 4x. Still have my plus 25 equals. This 10x minus 10x cancels. I still have negative 3. Okay, and then from there, regular equation. Subtract 25 from both sides. Negative 4x equals. Negative 3 minus 25 is negative 28. And then divide both sides by that negative 4. You get x equals negative divided by a negative is positive, and then 28 divided by 4 is 7. Did you subtract? Did you go the other way?
Yeah, I did.
Yeah, and that's fine.
Not completely different, but different of this.
Right, so did you start by subtracting 6x? Yeah. So Zach started by subtracting the 6x and is going to solve it in a completely different way to get the exact same answer. It's like sometimes I drive to work on the highway and sometimes I drive to work on 6th Street and I still get here and I still usually park in the same spot. Except for not this morning because there was a blue Dodge parked on the line of my parking spot when I got here.
Get out of here with that.
So,
Hold up. Wasn't like a what the Dodge again?
it was a blue Dodge car.
It's like a Charger.
Yeah. It kind of looked like a Charger, but I'm not sure if it actually was. Anyhow.
Can I go to the back?
Yes, you can. It's not First Sergeant's truck. Yeah. Hey, I know First Sergeant's bright blue truck. Hey, any questions? Sorry, video, that you're having to listen to me complain about this, but spread the word. If you drive that blue Dodge and you're parked in the first parking spot, Mrs. Ho wants to park in the second parking spot every single morning at 6 a.m., so scram. Someone on the cheer team, the dance team, or the drill team. Okay. Any questions? Okay, moving on from there then. This next one, the first thing that we need to do is distribute. So we're going to distribute negative 3 times 2x, which is negative 6x. Negative 3 times 4, which is negative 12. That is equal to negative 8x plus 14. Hey, from there, we have two choices. Since this is negative, we would have to do the opposite. So we could add 6x to both sides, or we could add 8x to both sides. I like to move whatever's on the right to the left, so I am going to choose to add 8x to both sides. So plus 8x, plus 8x. And conveniently, that actually gives us a positive. Negative 6 plus 8 is 2. So I've got 2x minus 12 equals, this negative 8x plus 8x cancels out. I have 14 over here. And I add 12 to both sides. Yay. I've got 2x equals 14 plus 12 is 26. And I divide both sides by 2. Get x equals 13.
Oh, yeah.
Okay. Any questions about any of the three equations we've seen so far? Yes. Yes, ma'am. John, just give that to Kim. Hey, in that case, we've got two more. The reason why we have two more, this one we have to distribute on one side and combine like terms on the other side. This one we're going to distribute and combine like terms on the same side. So it's just that prep work. If you guys haven't noticed, the ends of our equations always end up the same. Those last two steps are always the same. It's the steps, we're adding on steps at the beginning. So we added on, okay, sometimes you have to distribute. We added on, sometimes you have to combine like terms. Now we're adding on, sometimes you have to get things to the same side. So we're adding on steps to the beginning. The ends are always the same. Okay, so this one on the left side, we're going to distribute. 4 times 3x is 12x. 4 times 5 is 20. So I've got 12x plus 20 there. Equals. What can I combine on the right side? The numbers with the x's, the 4 and 5. So 4x and 5x is 9x minus 16. Okay, so from there, we can subtract that 9x from both sides. I like to move things to the left, but this also keeps things positive. On the left side, we've got 3x plus 20 equals negative 16. And we'll subtract 20 from both sides. We'll have 3x equals negative 16 minus 20 is negative 36. And then divide both sides by 3. X equals negative 12.
What?
Did you figure it out?
No.
Okay, I'll look at it in a sec, okay?
Okay.
Hey, now would be a great time for me to find my calculator. Where did I put it? It's usually right here. Somebody borrowed it, but then I put it back in my backpack, and then I thought I brought it. Oh. Yeah. Okay. So, as we get further and further into equations, you can still check your answers. So this is my show you how to check your answers one time in every note sheet intermission that I will do. So for this one, we know x equals negative 12. We need to plug that in here, see what we get for this whole side. Then we'll plug it in here and here, see what we get for this whole side, and then make sure those two sides equal out. So if I wanted to do that, I would do for the left side, 4, open parentheses, 3 times negative 12 plus 5, close parentheses. I would hit enter. I have negative 124. Okay? So then leave that in your calculator, plug in negative 12 to the other side, and make sure you also get negative 124. So for the other side, I would do 4 times negative 12 minus the 16 plus 5 times negative 12. Hit enter and cross my fingers. Okay, thank God. So if I plug in my solution to every x, my equation, in my original equation, it should equal out. Any questions about that shenanigans? The fifth one? No, I have it covered up. Yeah. Okay, last problem then. I always like to check the second to last one, because if I check the last one, people are already glooming and not paying attention. Very last one, negative 3 times x is negative 3x. So you always distribute first. Negative 3 times negative 7 is positive 21. And I still have my plus 9 equals 8x plus 8. So this one, I distributed on the left. And then I'm also going to combine like terms on the left. So all of my prep work is happening on the left, and I need to do it in 2 separate steps. Don't try to distribute and combine like terms at the same time, because you'll get off. So now I can combine my 21 and 9 together. So I've got negative 3x plus 30 equals 8x plus 8. Okay, I'm going to retract what I said. And I'm going to move my x's to the right. I know I said I would always move my x's to the left. You have 4 examples of that. I want to show you guys, and it's so much easier for the negatives on this one to do this. It's going to be way easier. So instead of subtracting the 8x, I am going to choose to add the 3x. Then on the left side, those cancel, and I still have 30, equals 8x plus 3x is 11x,
Oh yeah.
and I still have my plus 8. So this is a regular equation. Just instead of having 11x plus 8 equals 30, we have 30 equals 11x plus 8. So you solve it the same way. You're just trying to get x by itself on the right. So now I'm going to subtract 8 from both sides. 30 minus 8 is 22. That's equal to 11x. And then divide both sides by 11. 22 divided by 11 is 2, so I get 2 equals x. If you solve an equation and your x is on the right, at the end, flip it around and write x equals 2. Like the English language makes more sense, and it makes more sense to say x equals 2 than 2 equals x. That's like saying, hi, my name is Mrs. Ho, versus Mrs. Ho is the name of me. It doesn't, like, yeah, it's correct,
Then like robots.
but it's weird sounding. So, and if you forget to do that on a test, I wouldn't count it wrong. But maybe someone would in the future. So it's a good habit to get into. Okay, any questions about having variables on both sides of our equal sign? All right, in that case, let me stop this video.